All right, it's day 8 of Advent of Code. We're going to try to do this faster. All right, today's puzzle is called Resonant Collinearity. I don't even know if I'm saying that right. You find yourselves on the roof of a top secret Easter Bunny installation. While the historians do their thing, you take a look at the familiar huge antenna. Much to your surprise, it seems to have been reconfigured to emit a signal that makes people 0.1% more likely to buy Easter Bunny brand imitation mediocre chocolate as a Christmas gift. Unthinkable. Scanning across the city, you find that there are actually many such antennas. Each antenna is tuned to a specific frequency indicated by a single lowercase letter, uppercase letter, or digit. You create a map, your puzzle input, of these antennas. For example, this. So 0 and 0 have the same frequency. The signal only applies its nefarious effect at specific antinodes based on the resident frequencies of the antennas. In particular, an antinode occurs at any point that is perfectly in line with two antennas of the same frequency, but only when one of the antennas is twice as far away as the other. This means that for any pair of antennas with the same frequency, there are two antinodes, one on either side of them. So for these two antennas with frequency A, they create the two antinodes marked with the pound sign. Cool. Adding a third antenna with the same frequency creates several more antinodes. It would ideally add 4 antinodes, but 2 are off the right side of the map, so instead it adds only 2. 2 are off the right side of the map. Oh yeah, so this one, there should be another one over here that's off the map, and then there should be another one over here that's off the map, so those don't get counted. Antennas with different frequencies don't create antinodes. A and A count as different frequencies. However, antinodes can occur at locations that contain antennas. In this diagram, the lower antenna with frequency capital A creates no antinodes, but has a lowercase a frequency antinode at its location. The first example has antennas with two different frequencies, so the antinodes they create look like this, plus an antinode overlapping the topmost A frequency. So antinode. So that basically this is the one that kind of the topmost A frequency. So why is there an antenna here? There's an antenna here because A and A, or because pound. Oh, because of these two. So because of this one and this one of the antinodes is off the map and one of the antinodes is right here. Okay. So because the topmost A frequency antenna overlaps with a zero frequency antinode, there are 14 total unique locations that contain an antinode within the bounds of the map. Calculate the impact of the signal. How many unique locations within the bounds of the map contain an antinode? How many unique locations? So I guess that means that you could technically have multiple antinodes on. If you can have an antinode overlap with a then or with with another antenna, then you could probably have an antinode overlap with another antinode. This appears more confusing than I think what it is. So basically, when they say an antinode occurs at any point that is perfectly in line with two antennas of the same frequency. So basically, you've got a scatter plot. If you think of this like a scatter plot, like this. What the heck have I done? So if you think of you've got points basically that make up a scatter plot. And so all you're doing is you're picking 2 points based on a frequency. So let's say this is letter A. And let's say this is letter A. So these are two antennas of the same frequency. You're basically just trying to figure out, are they on a line? And then you're saying, after you say that, you're saying, oh, okay, my points are on a line, right? So there's A, my points are on a line. And then I just need to make sure that the slope, essentially the distance between these 2 points is 2 or more. And then if they are, that means that they have antinodes on that same line. So the first thing you got to do is you got to parse the puzzle. You got to get all your frequencies, and you got to group them by the character or the digit. Then you have to loop over them, and you have to compare them all. So if you have 3 A's, they're all going to have a position. Let's call it P. You need to calculate the slope between this guy and this guy. But you also need to do it for all the combination, right? So you need to calculate it between. Well, no, just calculating between this guy and this guy, right? Yeah, you just calculate. You need to know, hey, if the slope between two of these points is 2, it's 2 or more, then there's antinodes, and then you just need to calculate the antinodes by basically just adding a slope of 2 and finding the next point out here, which would be your antinode, and then antinode out here. And then you want to keep track of those spots because you only want unique spots. So we'll probably just add these to a hash set. But only when one of the antennas is twice as far away as the other. So maybe it is just twice. It's not even if it's a slope of 3, then we don't consider it. Okay. So let's do the first thing first. We're gonna parse our puzzle. So we're gonna have a class. This is gonna be a puzzle parser. It's gonna have a public method. And what's it gonna return? A list of frequencies, I think, is what we want it to return. Which a list of frequencies is basically a list of characters or digits. So
Did you see?
we're gonna say list of character, and we'll say parse string input like that. We'll just return an empty one right now. Return like this. And then, oh, we need some. We need some. Better. Okay, then we'll write our test class. So we'll say add class puzzle parser test method public async class parse when called or when given an example input should return expected list of then do we actually have an example input? Yeah, let's just use this. For example, this is our example. Copy. Async, no, private, read only, string. We're gonna call it example. This. This. We'll do this. That's our example. So we should basically have a list of frequencies, which is going to be 4 zeros and 3 A's. Where do we put the antinodes? This means that for any pair of antennas with the same frequency, there are 2 antinodes, one on either side of them. I guess they're just on either side each other just by whatever the slope is. I guess that's kind of how this example makes it seem like. One, 2, 3, 4, 5. Circle. In particular, an antinode occurs at any point that is perfectly in line with 2 nodes of the same frequency, but only when one of the antennas is twice as far away as the other. Is this twice though? This doesn't seem like twice. One down. Okay, anyways. Let's see. So var result should equal, we need a parser, private parser underscore parser equals new. Say. Then we'll say result equals parser dot parse example input. Oh, what's wrong? Wrong signature there. And then the result of this, I would expect, would be await assert dot that result is equivalent to a new list of char this. Which means we'd have 4 zeros. This. Doesn't like that. Can't resolve the next one. Say new lists. Then we'll have another one that's new capital A, capital A, capital A. You can use collection expansion. Nice. Okay, now I need to actually implement this. So I think what we want to do is we want to say var antennas this new list of character, and then we'll say for each bar line and input, and then for each bar character and line, we'll say if character dot is no, what is it? It's char dot is digit, or char dot is then we want to antennas dot add antenna or here, like that. And then we want to do antennas dot group by dot to list, and we just want to group by the character, right? How does There's elements in a group. A function to extract the key for each element. I guess I've never used group by before. So, list of pets, group by. I think I just want to how to group by, how to group list in C#. Yeah, here's what I want to do. So, like,
TD6. 6 is like 0.
list of characters grouped by C#. How to get a list of grouped values. Yeah, I don't know what I'm doing here. Group. List. Because right now there's just a list of characters. And I basically want to turn that list into, I want to take that whole list and just, if I have a list that looks like this, 0, 0, 0, and let's say it's like this, A, and I want to turn it into this. And this seems like a trivial operation that I shouldn't really need to solve for. I feel like this is something that should already be possible to do. List of characters turn into group groups of groups based on value. I'm thinking so I can't just use group by. That's what I was. That's where my mind was going. Doesn't seem like it works the way I thought it would work. Excuse me. What if I change this from a simple list to what if I make class? Actually, it can be a record, just a value. Record. Antenna. And that's going to have a row index. Row index. Int call index. And then a char, which is the frequency. That. Don't even need that. Then what if we do, instead of just this, we do a list of antenna. What's this? It wants me to do a link. I'm going to say dot select line index line index. Just return those. Say line index, row. This will call this row index. Right? Yeah, that's the row index. And then we'll do line dot select, and we'll do char character character index, and return that. Line, yep. Character column index. And then instead of just that, it's going to be new, row, column, and character. And then down here, I'm thinking that this will let me say antenna group by a dot frequency dot to list. And then this is actually going to say antenna. What does this return? Bar groups antenna group by frequency. What's this? Return that. And what's the return type? This is a list of I grouping. Oh, okay, interesting. I don't think I've never used group by before. So the return is actually going to look like this. So is I grouping basically just kind of like a dictionary? I grouping C#. Yeah, it's just like a dictionary. I'll be right back. I'm gonna go. It's bedtime here, so I'm gonna go say night. I'll be right back. Yeah, sorry, my mic was muted. I forgot to turn it back on after I went to say goodbye to my kids, or goodnight to my kids. Let's see. Find the equation. It's not going well. I'm struggling through this one a little bit. If one distance is exactly double the other, then the points are considered twice as far. Yeah, I don't understand. I don't understand what twice as far away as the other. Oh shit, I'm at an hour and I still haven't gotten even. I mean, I know I can calculate the distance between the 2 points, but that doesn't tell me anything about how far away they are. And how far are they away from what? The midpoint? Do I calculate the midpoint and say yeah, I don't like here, right? Like why is this one 1 1 2? 1 2 3 4. But the distance between these is 5-ish. The distance between these is 2-ish. I don't know, man. The point is on the same line. The point is on the same line as 2 antennas. And one antenna is twice as far from the point as the other. Really? That seems so. Okay, so I've been looking at this wrong. So we basically are walking through this grid. And checking if the point is on a line with 2 antennas. And then taking the point, taking the distance from this line to this line, and then the distance from this guy to this guy. Oh, okay, so that's where the third point comes in. and then I calculate this thing. So yeah, this see, but it seems like overkill because I'd have to check this point against all antennas, against the position of all the antennas. What's my puzzle input look like? Yeah, that just seems like a lot, but maybe. Yeah, get that. Yeah, I'm just having a hard time, I guess, thinking programmatically about this. So I guess I check. Like if I start here, I guess what I'm thinking is I'm trying to see if this is an antinode, and the only way I know if it's an antinode is by checking if it's on a line with this antenna, which by definition, if I create a line between, if I have 2 points, this point and this point, that's a line. And then I guess I would just then check the next A to say, hey, is this second A on the same line, which it's not going to be. This isn't going to be an antinode. But I then need to do that with each frequency that I have. I need to do that. Oh, okay. Yeah. So that's what I'm thinking is like that brute forcing this seems really difficult. But I'm having a hard time thinking about how I get from these two, you know, if let's just say I have these, I parse the input and I know I have two A's. How do I calculate that these are twice as far away from each other? How do I say that? How do I what is the characteristic that I use? That's the part I'm not understanding. Is it purely just because this is on row 4? No, 0, 1, 2, 3. This is on row 4. This is 0, 1, 2, 3, 4, 5. This is on row 5. So, yeah, I don't know why would that make them twice as far away from one another. This is the first one I feel like I'm gonna have to go to. I'm gonna have to go to the maths on this one. I don't understand it. I mean, I understand the brute force thing where I'm basically now I'm checking every dot against every frequency. I'm gonna have to go to the Reddits. The antennas aren't twice as far away from each other. An antinode is twice as far from the near antenna as it is from the far antenna. So I think what you're trying, or what then that mean, what that basically means is, okay, so I have a line A, and then I calculate where the antinode would be based on that. So I know, like, if I know, so I know if the rise overruns 4 here, 4, 0, 1, 2, 3, 4. Or no, it's 0.5. Then what you're saying is, then I know the rise over run is twice that, so it becomes 0, 1, 2, and then 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7. Hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. 8 spots. Okay, I think my brain is starting to. Wrap around this. 0, 1, 2, 3, 4. So if we say this point's at 4, 0, 1, 0, 1, 2, 3, 0, 1, 2, 3, 4. Then we say this one's at 5, 0, 1, 2. 0, 1, 2, 3, 4, 5. And then, yeah, so 5, 5. I guess it's more like so then that line has a slope of 2. Minus minus 3 divided by 4 is 2. 1, 2, 1. Or actually, you're saying I basically this to this, and then twice that would say 4, 1, 2, 3, 4, 1, 2. Okay. Okay, I see. I think yeah. Okay. Twice that. Oops. Man, this one has me down bad, honestly. So why doesn't this give me the result I would expect? Would be 4, 5 minus 4 equals 1. And then should be 2. This is x1 minus, or x2 minus x1 y2 minus y1. 2 divided by 1 equals 2. Rise over 1. End. Oh, it's because I have these flipped. Yeah. Okay. So if I can calculate the slope, then I can calculate the slope between these two things. Then I can say, okay, there's an antinode twice as far away over here, which would just be on the same line. I just need to double the slope, so I just go up, up, 1, 2. Yeah, so I just go up 4. In this case, up 4 over 2. So maybe then instead of a slope, I want actual rise over run. Record slope and run. Say I have no idea what I'm doing, but we're gonna try to get there. Actually, I think I don't have to expose the. I could probably actually make this private, read only, slope, and then instead of that, could I have a method that says public list of points actually it's not really a list, it's just a tuple. It's just two things. It's a no, it could be a list. It's a list. List of points which are essentially my antinodes. Get antinodes. Is that all one word in the puzzle? I don't know. Eldon, I don't know. Without your help, man, I would have been stuck, I think, on this one. So I appreciate you. trying to make it clear to me. Yeah, they call them antinodes, one word. So get antinodes. And for now, just turn an empty collection. And so what does that mean? So to get an antinode, there's going to be two possible ones. There's going to be one over here and one over here. So we can start by calculating this one using the end point. So whatever the end point is, we're going to go twice the slope. So add a private get antinode. That's get antinodes. And so we'll say our first antinode So first antinode is going to be located at new point, and it's going to be end end dot row index we want to move that way, so it's going to be end row index minus the slope dot run times 2 to be twice so far away, and then n dot column index minus slope dot rise times 2. Or double slope time double slope dot minus 2. So let me just think about that. Would that give us that antinode? What's up? Open that up. Program.cs. Okay, so that would give us, if we're in this example still, if I use the end, and I say row index should be 0, 1, 2, 3, 4, 5. So this is and then it would be minus double the run. And in this case, the run is just 1. That would be 5 minus 1. No, sorry, be 5 minus 2. So that would be go from 5 to 0, 1, 2, 3. Yep, that puts us in the right row. Right row? No, right column. God, I keep getting row and X's and Y's and columns mixed up. So we're talking about, when we're talking about rise, we're talking about columns. When we're talking about run, we're talking about yeah, this should be flipped. When we're talking about rows, we're talking about rise. When we're talking about columns, we're talking about run. So yeah, so this would be 5 minus double 0, 1, 2, 3, 4, 5. Yeah, so 5 minus double the rise, which in this case the rise is 1, 2. So this would be 5 minus 4. So that puts us in this guy, 0, 1. Yep, right row. And then puts us in, yeah, that's right. Pretty sure that's right. So then we do the same thing, but this time we do var second antinode equals new point, and that's going to be end, or no, start row index, and that's going to be plus double the run, double the rise, and start column index plus double run. We'll just return first antidote, second antidote. Alright, not antidote, antinode. Okay, so yeah, so then if I go back to my line thing, say await assert dot that line dot. So now we want to get the antinodes. So we say if we're given these two antennas at those two locations, those 2 points, we can say var result line dot get antinodes to wait assert dot that result that is equivalent to there should be a list of points, and these should just be the points we were expecting. Oh, I can't use that. I have to actually use point. So yeah, so what do we want this to be? 0, 1, 2, 3, 3, 1. And then this should be 0, 1, 2, 3, 4, 5, 6, 6. Or 1, 2, 3, 4, 5, 6, 7. It is why doesn't it like this? Expected results to be equivalent to new. Doesn't make any sense. Maybe this is just because I don't understand the assertions. Expected result to be equal to 3, 1. God, I did it again. Keep flipping these. Flip these completely. That represents X. I mean, I really just need to make up my mind. So this is Y, and this is X. This is Y, and this is X. Over here, that's X, that's Y. One, 3, 6, 7. Column index, and this should be flipped. That's why I'm confusing myself, is because in my code I'm writing everything YX, and in my brain I'm thinking of everything XY. Excuse me. Oh, I'm losing my enthusiasm at the moment. There we go. Gosh dang, man. Okay, so we have a way to calculate our antinodes now, which is cool. I think what I'm going to do then is I'm going to pass in the input to the line. Because I think what I'm going to do here is I'm going to say var result equals new dot parse var antennas grouped by frequencies. And then for each one of those, each or group in this we need to say for I is less than group dot count. Another floor. Again, our number of antennas equals dot count. Going to be our antenna group dot key, not key, group dot group dot to list. So antenna 1 is going to be and then line equals new line of and bar Anthem nodes get antinodes. They're just points. Are what was the question? The question was there are 14 total unique locations that contained within the bounds of the map. Calculate the impact of the signal. How many unique locations within unique locations? Yeah, so then I'll just have var antinode locations equals a new hash set of points. The last check I need to do here is var is possible antinodes antinodes equals possible dot where a dot is on map. Give it the input. Return row index is greater than row index is greater than -1 and row index is less than map dot count or length -1 and column index is greater than -1 and column index is less than map first row dot length -1. Say antinode have to actually say. Why is it complaining about that? Whatever. Okay, and then I'm gonna do something super in the name of testing. Just I'm gonna have a public static class called antenna. No, public static class called antenna grouping. To be get anti-nodes. I do not like this. I don't like my API of all this. I don't exactly love my solution, but I think I can reorganize this. Yeah, just I just saw that comment. Just switch your brain to row column. Then yeah, I know. I keep messing myself up with X, Y, row, column, row. Okay, so we do. Basically, just gonna move all this inside here. This is gonna say this I grouping. just gonna call this result for the moment. The inner of solution or when given example and should return expected going to be equal to 14. Wow, this one was, I don't know why this one was so hard for me. About 18. I'm thinking those are the ones that are off the map. One, two, three, 4, 5, 6, 7, 8, 9, 10. 1. Oh, and then yeah, one on here. Okay, so there's some maybe that I'm including that shouldn't be included. Or maybe this hash set isn't working the way I envision the hash set to work. No, this is no, this is overkill, but I just want to see if Okay, so it's not that. At least I don't think it's that. Oh, whoops. One, click back here. Do I have any duplicates? No. Do I have any that are off? 1010. How long is the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? 1, 2, 3, 4, 5, 6, 7. So it's 12 wide. One, two. Yeah, it's 12 wide. Okay, I'm not going to be able to search just on count. I'm going to need to... Okay, good. I'm glad I'm not the only one who thought this was a weird one, because like it really, it really screwed me up. Okay, so I'm actually going to have to make sure I get the right locations to be able to debug this personally. I mean, I'm proud of myself for not having called it quits yet, because I don't, my motivation has, is waning. It's a new list of points, but we're gonna stick with it. We're gonna get this. So the first one here is let's see, 0, 1, 2, 3, 4, 5, 6. And it's on the first. New 0, 12, I think. Or no, 11. I don't think I have that one. 0, 11. 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, that'd be 11. So I don't think I saw debug my result. I'm pretty sure I did not see a 0, 11, did I? I see a 0, 6. So I have more than what I should. So I have more than what I should. But not all the ones I should. Yeah. Okay. Let's not filter for this for a moment. let's just see all the nodes that we're getting. There's 23. So there's my 011. I filtered that out. That's because of this. That logic was wrong. Okay, so that's good. So that where is on map, but actually I think I called this A. T node. Okay, now I have 20. I just have a 0 and I have an A, which is the right grouping. But I have too many antinodes. So, okay, then let me look at this hash set again. Debug. None of them are duplicates, it looks like. And these should be all off the map. So there must be some logic that I'm missing. Must be some logic that I'm missing. About which antennas there's some logic that I'm missing here. Yeah. Trying to think about how I want to debug this. I guess what I want to know is which ones I have and which ones I don't, I guess. It's kind of painful, but we'll say new 1 1 2 new is 2 0 1 2 3 4. Two, 11. Right, yeah, 0 1 2 2 0 2 3. 0 1 2 3 4 9 5 1. Danger with doing this is making sure I actually read this puzzle right. 0 1 2 3 4 9 5 1 2 6 6 0 1 2 3 6 3 2 0 1 2 6. Oh, this is actually 1 2. 1 2 0 1 2 3 5. 7 8 9 10 10 11. 1 2 3 4 5 6 7 8 9 10 11 12 13 14. And 1 this is silly. I can do this better. I can say stop. Lower delta equals result dot where back to contains whoops, where a contains a false. 826 18. But why would it think there's an antinode there? Question. Well, how would I don't want to know the antennas that generate this. I'm not sure why it would think that. Why does it think there needs to be one there? Is it because it compared? I'm gonna have to see to figure this out. I'm gonna have to do something wacky. Get antidotes. It's gonna be antinode results. And this was going to have antenna first, antenna second, and then a list of points, which are the antinodes. And this is going to be var result equals new list of dot add new 1, 2. Okay, first thing I want to get is I want to get the delta. So I'm going to debug this, get out my handy dandy notepad. Meet 25 37 44 8 9. I wish I was smarter than this. I wish I could figure this out without being such a klutz at it, but I just don't have a better way at this point. $10 o'clock. Alright, I'm ready to probably be done if I can't figure this out pretty quick. Let's see. So we are looking. Okay, that's just not. That's just weird. Row. These have the exact same position. Oh, it's comparing against itself. It's an off by 1 error. Isn't it? That's what's happening. Because these need to go back. This needs to go back to a for loop. Which is why I wrote it probably like a for loop to begin with. Convert 4. Convert. No. This guy. Convert 4, and then this needs to start at 1. Right? No. Maybe I just do an equality check. Leave it at for each, and then just say if A1 equals A2, continue. Let's see. Stop this. Debug. There we go. Yes. Okay. Oh man, that's frustrating. Okay, stop. Okay. But yes, stop. Remove this result stuff. I'm tired of this telling me I need to convert it to a link. Do not show. Now let's see if it's the right set of nodes. Order's probably off. Let's just do it in the order they have it, or the order it actually returns in. 3, 2. Well, before we do that, let's make sure we have all the same ones. So stop. This should just be it. Delta should be empty now if we do have the same ones. Delta is 0. Awesome. Okay, so it's just an order thing. So we can just do 0, 11, 2, 5, 6. 7, 0, 3, 9. 0, 6, 6, 3. 10. 5, 1. 2, 4. 10. 7. 7 and 10, 10. Yes. Okay, cool. Oh, fantastic. Now let's try to actually run this on the puzzle. On the puzzle input. Dang, that was a tough one for me. It really was. And I don't really like the solution, how it's worked right now, so I probably want to come back to this just to do. Make this better. It's ugly. It is ugly. .NET run -- project is going to be 08 Resonant Collinearity 8 Resonant. Do I not have an input file in there? Oh, of course I don't, because it's here. Oh, whoops. Result dot count, or I guess we could just say count. $228. Yes, let's go. Oh my god, that was my longest part one so far. 2 hours and 45 minutes, and I would have not, without the help of chat, I would have not probably got that done. Because the thing that kept throwing me off, the thing that really threw me off was this bit about only when one of the antennas is twice as far away as the other. Yeah, that one, that sentence, this sentence right here really tripped me up. Okay, so part 2. Let's see how bad part 2 is going to trip me up. I don't even feel like starting part 2, honestly, but we're going to give it a try. Maybe it's not as bad as I think it is. Or maybe it's not as bad as I think it's going to be. Part 2. Excuse me. Okay, now let's see what it wants us to do. Watching over your shoulder as you work, one of the historians asks if you took the effects of resonant harmonics into your calculations. Whoops. After updating your model, it turns out that an antidote occurs at any grid position. Any grid position exactly in line with at least 2 antennas of the same frequency, regardless of distance. This means that some of the new antinodes will occur at the position of each antenna, unless that antenna is the only one of its frequency. So these 3 T frequency antennas now create mini nodes. Oh, so you're basically just carrying that out all the way till you are off the grid, essentially, in either direction? In fact, the 3T frequency antennas are all exactly in line with 2 antennas. So they are all also antinodes. Oh yeah, because an antinode can be on an antenna. This brings the total number of antinodes in the above example to 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So the antennas themselves are antinodes, and then you've got to calculate the next antinode, basically until you run off the. So the original example now has 34 antinodes, including the antinodes that appear on every antenna. Yeah. Well, I need to refactor the solution anyway, so I'm not going to try to do this in the most pretty way. I'm just going to do it in the way that works. So I really only need to change this. And I'm going to call it, well, actually, instead of doing this here, yeah, instead of doing that here, I'm going to pass that in here. That's not the right. I keep defining the signature like that. I don't know why. Input, or let's call it map because it's actually the map. And then be a new. List points. Yeah, actually, I'm not even gonna do that there. I'm just gonna put it up here. Now I gotta go fix this. And I've gotta go fix my test real quick. Now this needs the example input. Yeah, the parser needs to return back a map. I need like a map object, and then I don't have to do all this, but this will work for now. Let's make sure my test still passed for solution 1. Yeah, that's fine. Okay, so now my antenna class also shouldn't be it should have a point. It should just be point frequency. It shouldn't have its own row column index. It should just be its own point. But do I want to change that now? No, I don't want to change that now. I just want to get to a solution. Because all I'm going to do here is I'm just going to have another method that's called public list point get part to antinodes. And this is going to be a little different. The only person that uses that slope is in here. And the only reason I use it is to double it. So I'm just going to go ahead and double it here. I'm going to call it that underscore doubled slope. And then this is going to be called doubled slope dot rise, and slope dot rise, run, slope dot run. So for here, we just need to say var var antinodes. This new list of points, and we're gonna say so var current point, and we'll just do the start, and we'll say while current point is on the map, we will antinodes.add that point. So or we will add the current point. So this should factor in the start. Yeah, that should factor in the start. So the start will get added. Then we'll calculate the current point again, and we'll say new point for the start is going to look like this. Which is kind of interesting because that now makes me think I need something in here that's like private point get next point from start. That basically does this. No, let's not. Because we're iterating, so this actually needs to be current, and we can return anti-nodes. Now, then we need to do the same thing with the endpoint. So then we'll say current point equals end, and then we'll say while current point dot is on map. The only difference is we'll still add it, but now when we calculate it, we should be doing this, right? We're basically just minusing. What do you think about that? So this is calculating from the end. If we go back to the original example, if this is my end node, this is the one I want. Because the end node's basically going to go back up the line. The start node's going to go down the line because we're doubling. Like in this case, we're going double. Oh no, we're not doubling anymore, are we? We're just... regardless of distance. Regardless of distance. So now we don't even have to double the slip. Gosh dang it. So my earlier refactor took us in the wrong direction. Underscore slope. So this is slope rise, slope dot rise times 2. Dot rise underscore slope dot run times 2 underscore slope dot run times 2 run dot run. Okay. So this is just going to be slope, and then slope. And then it really doesn't matter so the end, so when we're at the start, this can actually work in the other direction. We can just work back from the start. And then this can just work forward. What we're doing here is we are finding points from end antenna out. Finding anti. We are finding antidotes from start. But now that I'm looking at this, why are all these filled in? It's hard to tell what belongs to what. But I think where's my original? So these belong to these guys. And these are just working all the way back. Yeah. Okay, let's give this a shot and see what happens. So we'll say get Andy notes, and we'll say bool part is part 2. It's false by default. Song is not doing it for me. So yeah, so we'll say nodes dot to list, and we'll say is part 2. Otherwise we'll do line.get. I guess we don't even need the list here either, do we? Rechanting that. Okay, so part 1 should still run. Method not found. It built okay. Yeah, okay, that worked. Huh, I wonder why that errored. Okay, weird. So let's try part 2 with the same example input, but instead of this for now, solution part 2. Say dot count is 30. What did it say? 30, 34. Yes, okay. So let's try running this on part 2. All we have to to do there is just say, is it part 2? Gosh dang, this was a tough one, and it's uglier than sin. If day 8 is whooping me like this, I don't know, my goal of making it through day 15 might be a stretch. There we go. All right. I'm gonna git add git commit m feature. Oh, let me actually update the README real quick. This will actually be like a really fun one to come back to in the morning and massage a little bit, make it a little bit, just a little better. This one was called, it's called Resonant Collinearity. It's a mouthful. Without some help from chat, this, I don't know where I'd be. To be fair, the description kind of misled me. I mean, I'm sure people have different opinions, but why do all these just say installing? Install. Okay. Day 8 solved. Day 8 part 1 and part 2. I also need to I need to make this ugly better. It is ugly. To do add s for actual input and corresponding solution. Okay, that's gonna do it for me. I'm honestly sorry that that was so painful, probably to watch, and I don't know how much help I was at helping anyone solve it, but yeah, I'm glad I got that done. Got through day 8. Hopefully, the next couple days are a little easier than that. I'll see you guys. I'll see you next time. Thanks for your help, chat. Appreciate it.